Hi, this is catupper. I will solve Atcoder Beginners Contest 168 with English. And there is update at this notice. I will use Python by 3 if I need. I got some advice that Python 3 is a little bit faster than Python. Okay, so it starts and open. Oh, that's very funny. The statements are all consist of dot. And I will change the language to English. Sorry, so I will change the language and open the problem again. 1, 2, 3, 4, 5, 6. Okay, so problem A. Therefore, the cat Snook wants to play a popular Japanese game called Atcoder. So Iroha has decided to teach him Japanese. When counting pencils in Japanese, the counter word hon follows the number. The pronunciation of this word varies depending on the number. Specifically, the pronunciation of hon in the phrase enhon for a positive integer n not exceeding 999 is as follows. Hon for when the digits in the ones place of n is 2, 4, 5, 7, 9, and pon for 0, 1, 6, or 8, and bon for 3. Yeah, it's very famous Japanese factor. Given n, print the pronunciation of hon in the phrase enhon. Okay, so just check the ones place of digits and just write the if statement. So get let's move to directory. This was 168 and open 8pi and zoom up. So just get the n and calculate the ones. It's just dividing by 10 and get modulo. So n is input if n mod 10 in. This is the useful functionality of Python. You can use in statements. 24579. If it in 24579, 24579, and print home and do something same with it. If it's in 0, 1, 6, and 8, 1, 6, and 8, print pon. And otherwise, print bon. Okay, so let's check this with all digits. 0, no, pon. Okay, so sample 16, pon, good. With 2, hon, and with 183, pon, great. Okay, let's submit with this. Submit. Okay, and next problem, B, triple dots. We have a string S consisting of lowercase English letters. If the length of S is in most k, print S without change. If the length of S exceeds k, extract the first k character in S and append 3 dots, triple dots, to the end of them and print the results. Okay, so we can use slice, the functionality slice of Python. This is a famous what's brand. And okay, so get S and compare the lengths with k, and if it exceeds k, just slice and add triple dots. Simple if. Get k and get S. Right. That's all. And if length of S is no more than k, just print S, and otherwise print the first k letter of S and add triple dots. Okay. B pi. Let's check with this. If we get Nico and triple dots, it's okay. And if it doesn't exceed, just output the same thing. Okay, so let us submit this. How was it? And A was AC. Thank you. Next is problem C. Colon. Consider an analog clock whose hour and minutes hands are A and B centimeters long, respectively, and an endpoint of the hour hand and an endpoint of the minute hand are fixed at the same point around which each hand rotates clockwise at constant angular velocity. It takes the hour and the minute hands 12 hours and 1 hour to make one full rotation. It's the ordinary clock. At 0 o'clock, the two hands overlap each other. 8 hours and m minutes later, what is the distance in centimeters between the unfixed endpoints of the hands? Okay, so just calculate the coordinate of the endpoints and unfixed endpoints, and just take the distance. Oh yeah, this is famous right triangle. So the length of short one and long one, and hour and minutes. Okay, and so we have to do some fundamental arithmetics. So we have to calculate the angular. So with it's too big. This is too thick, so I'll change the thickness of the pen. I found it to size 5. Okay, so it's a o'clock with hour is A and minutes is B. In this case, the long one will be the angle of long one is pi divided by 60 and times B. Okay, and short one will have 2 pi divided by 12, 24, which is it? No, 12 is, yeah, 12 and times A. Okay, that's all. And what is the coordinate? The position of the unfixed endpoints is just sine. Okay, this is theta minutes, and this is a theta hour. The coordinate is cosine theta minutes and sine theta minutes. This is not the same, but you can translate this to this. And same thing will happen here. No. And times the length of minutes. The length of minutes times length of hour. Okay. And just take the distance. This is not difficult. Theta pi, get length of A and length of B, and no. Which one is long one? A is short one, so get length of hours and length of minutes and the time. Hour and minutes with space separated. And input split, and let's use mass. Import mass. And okay, so what we need is minute x is hour x is sine. Do we have pi? Not pi. Okay, I have it. Pi times 2 times hour divided by 12. And same thing, hy is sine. Next, minutes. This is not 12, this is 60. And this is not age, this is minute. And just print the distance. No. Since the distance doing this is square root. Okay, so let's make a distance function. Maybe there is in math, but I don't know the name. Distance of A and B. X1, Y1 next to Y2. The dx is x1 minus x2 and dy, or y1 minus y2, and return the square root of the sum of the square plus dy square 0.5. And just the distance of hx, hy, mx, and my. Okay, I forgot to close the parenthesis. And oh, what's going on? Ah, yeah. We have to add math dot here. This is simple math. Okay, let's do with seed pi 3490. Oh, there's no pi. There is no pi, so I will give the pi. No pi? Really? And pi is something like this. Okay. And 3490. 110. Really? Really? Okay, let's print hx and yx. Hy, mx, and y. And 3490. Let's copy this and just paste. So 0 minus 1, 1, 0. Really? Oh yeah, I have to multiple the lengths for it. And then why this big? Yeah, okay, so let's print dx and dy. It's correct. Oh, so maybe. Ah, yeah. I thought I missed the formats. Yeah, okay, this is okay, I think. Maybe my pi is not accurate. How about 20 digits? Ah, okay. I think that's okay. Try again. Oh, not okay. Why? Think length of hour, length of minutes, hour and minutes. There's 12 hours. There's 60 minutes. Why is like that? Ah, yeah, I know. So the short one is not so okay, so I have to use m at here to calculate the coordinate of hour. Okay, so this is divided by 140. So they go around in 140 1040 pound. Okay, so 1440 minutes. So divided by this and convert into the minutes. Okay, this is what I need. And I will get the correct answer. Yes, it is. Okay, so let's output and remove the back and open it and submit it. Oh, and let's do D, double dots. There is a cave. The cave has n rooms and n passages. The rooms are numbered from 1 to n, and the passages are numbered from 1 to n. The passage I connects. Oh, this is just a graph, bidirectional graph. The room 1 is a special node. It is dark in the cave. We have decided to place signposts in each room except room 1. The signposts in each room will point to one of the rooms directly connected to the room with the passage. Since it is dangerous in the cave, our objective is to satisfy the condition below for each room. If you start in the room and repeatedly move to the room indicated by the signpost in the room you are in, you will reach room 1 after traversing in the minimum number of passages possible. Determine whether there is a way to place signposts satisfying our object and print one such way if it exists. So it's just write the signposts for the nearest neighbor, the neighbor nearest to node 1. Then we can calculate the yeah. So when it goes no, is the some node is not connected to. Oh no, there it says it's connected. So we don't have no. We have no. And so we just calculate the distance from 1 and find the nearest neighbor and write the index of it. Oh, and yeah, I got the wrong answer. I think my pi is not good. So do it. Python pi. How can I get pi? Math with pi. Okay. Import as pi. Okay, this is what I need. Math pi. Okay, and let's submit it. C pi. And what we need for D is just calculate the distance from node 1 for each node. So just get n, m, and m edges. Oh, I got wrong again. What's going on here? Yeah, I get wrong answer with the sample. So let's check with the sample input. No. Sample 2 says 4.56425719433. I got the correct answer. How about this? Wow, I got the wrong answer. Why? Hour minutes. Why? Okay, so print hx, hy, and mx and y. What? Yeah, so minutes gets the correct coordinate, but the hour get the wrong one. Why? 60 times h is 9,450. Yeah, it's 120 for half of the day. Yeah, I got it. Okay, so I miss the arithmetical part. And this will get the correct answer. Yay, so let's solve the D. And get N and M. This is number of node and number of edges. And input split. And get M edges. A and B. Get A and B. How many nodes are there? Many. So we can use BFS. Edge. This is the adjacent list. Maybe we can just name this as edge adjacent, and it has an empty list. No, we add this to here, and B. And don't forget to convert this to zero index. So 0 1 B 1, and for just to BFS, so Q. I have Q with empty Q, and yeah, so for I in range. Oh yeah, is there a Q in Python? Q. Oh yeah, there's it. I'll change it to English document. This is yeah. So leave a Q. Let's in fast add Q. Can we push and pop? Let's get put and get order. So okay, so we can just put, and we can just get okay. Okay, so just import Q. Q with small, and Q equal to Q dot Q. Okay, so Q put 0. This is the starting node, and while this is not empty, is there an empty method? Is empty. I want to just check, is it empty or not? Yes, there is it. So it's not empty. Do something. Now is the front of it. Can I pop it? How to pop? Just get means to pop, remove, and return. Okay, so is it remove the last one. Okay, so I'm at now, and let's look for adjacent list now. If distance of 2 is already determined, and just skip. This is not 0. No, minus 1. Continue. Distance 2 is distance now plus 1, and just put to Q. And at this time, we can determine the value of the sign pause. The answer of 2 is now. Answer 2 is now. Okay. So let's define those lists. Distance is the list with size n, initialized with -1, and answer is whatever the element is, whatever answer the length of n. Times n. Okay, so why is red? I don't know, but I've done the BFS, so y range 1 to n, print answer I plus 1. Because we converted into 0 index, we have to convert it to the 1 index again when we output. So, and don't forget to print yes. Okay, so try C pi, copy, run, go. Put missing. Where is it? Oh, put need 2 arguments, really? Put. Oh, it seems it have only 1 argument. Put item into the queue. Oh, maybe this queue is what we need. Simple queue. Descriptor put requires a queue, simple queue object, but received hint. Oh, I don't know how to use this. Is there any example? There's many Japanese articles. Ah, yeah, there's it. But this is not queue. Pop 0 will take the linear time with the simple list. So yeah, this is what we need. No, this is the queue bots. Look. Okay. This will satisfy what we need. From collections, import queue. Queue is initial stack. And not put, append. Which is left and which right? Append. Left is the fastest one, so get is pop left, and not put append. And it's okay. Oh no, empty. I think we can get length, so this is not, we'll just compare with this with 0. Okay, 1 to 2 is correct. How about this? Oh, 6 5 6 1 1. Maybe it's okay. So let's submit it and check it. Go. Now I got correct answer with C. And let's check it. Is it accepted for D? I will cut this video out here and take new 2 videos for E and F. And it seems it's going good. It's fine. Okay, so thank you for watching. Next problem is E.